Okay, here's a picture of what's going on. We've got this implicitly defined relation, and it does pass through the point 1, 0. This red stuff is part of the graph of that relation. The green line is the tangent line to the graph at the point 1, 0. And this purple line is the normal line, perpendicular to the tangent line. Okay. Now the question is, how do we get the equation of that normal line? That's what we're asked for. Okay, so here's the original function. We're going to have to implicitly differentiate with respect to x and find y prime. This first term, we'll have to use the product rule, where e to the y is the first function and tangent of xy is the second function. So I'll use the product rule. The first function times the derivative of the second, that's all of this right here. Derivative of tangent of anything is secant squared of the anything, secant squared of xy. And then I have to apply the product rule to the inside, chain rule. So it's the first times the derivative of the second plus y times the derivative of the first, which is just x. So that's the first part of the product rule for this first term. This is the second part of the product rule. The second function times the derivative of the first, which is just the same thing. Now the derivative of this minus ln of x squared minus 3y, the derivative of ln of anything is 1 over the anything. There's 1 over the anything times the derivative of the inside, chain rule, 2x minus 3y prime. And over on the right, we're going to use the power rule, followed by the chain rule, followed by the chain rule. So we'll bring this 2 down to the front and have sine of pi x. Now we multiply by the derivative of the inside, which would be the cosine of pi x. And then we multiply by the derivative of the inside cosine and just get pi. So there is the implicitly defined y prime in terms of x and y. If you had to solve for y prime right now, that would be, I don't know, very painful. But thankfully, we're told that the 0.10 is on the graph, the original function, and here's actually a confirmation of that. If you put 1 in for x and 0 in for y, you do get a true statement. So all we have to do is plug in 0 for y and 1 for x, and then solve for y prime. That's much easier than trying to isolate y prime to start with. And I'll let you go through that. But what happens is you get 4y prime equals 2, so y prime equals 1/2. That means the slope of the tangent line at the point 1, 0 is 1/2. How do you write the equation of the tangent line? If you had the equation of the tangent line, it would be y minus 0, using point slope, equals the slope times x minus the x coordinate of the point that you know about. The normal line is perpendicular to the tangent line, so the reciprocal, negative reciprocal of 1/2 is -2 times x minus 1. This is your answer right here. Okay, and for confirmation, there's what the equations on the Desmos graph look like. This was the normal line right here. Okay, hope that helped. If you have any questions, post a comment.